So now that we know how to find vertical asymptotes and how to find horizontal asymptotes of rational functions as well as any holes, let's put all of that information to use to sketching graphs of rational functions. All right, when you guys go to sketch a graph of a rational function, follow these guidelines. There's a few of them, so make sure you take some time to get these into your notes. All right, and pause the video if necessary. Number one, rewrite the numerator and denominator of the function in factored form. All right, we want to factor the numerator and the denominator. Two, determine the domain of the function by finding the zeros of the denominator. Remember, anytime that the denominator of a fraction equals 0, the function is going to be undefined. All right, so finding the zeros of the denominator will tell us our domain. 3, find any vertical asymptotes and identify the existence of any holes. Remember, to find vertical asymptotes, first, cancel any common factors between the numerator and denominator. The remaining zeros of the denominator will be your vertical asymptotes. Any other undefined values will result in holes in the graph. 4, find any horizontal asymptotes. Remember, to find horizontal asymptotes, we must analyze the degree of the numerator and the degree of the denominator. 5, find the x-intercepts by locating the zeros of the numerator that are not common to the denominator. Remember that a fraction only equals 0 if the numerator is equal to 0. So cancel out those common factors and find the remaining zeros of the numerator. Those will be your x-intercepts. 6, find the y-intercept by evaluating f of 0. Y-intercepts are where the graph crosses the y-axis, and we know that x equals 0 there, so we plug in 0 into the function. What we get out will give us our y-intercept. 7, sketch the characteristics found above, and then plot at least one point between and beyond each x-intercept and vertical asymptote. And finally, use smooth curves to complete the graph. So let's go through a few examples here, right? Again, make sure you have this entire list out in front of you so that we can begin to follow through. Now, on your test or quiz, you're not going to have to memorize all of these steps. Know that I will ask you to determine the domain, the vertical asymptotes, the holes, horizontal asymptotes, so on and so forth. So you won't have to remember all these steps, but you do need to remember to factor the numerator and the denominator. All right, sketch a graph of the function. And again, it's important to recognize that we're dealing with a rational function. We have a polynomial divided by a polynomial. That's what makes this a rational function. So we begin by factoring the numerator and the denominator. The numerator here factors into x plus 1 times x minus 2, and the denominator factors into x plus 5 times x minus 2. This will allow us to find the domain. Again, recall that a function will be undefined anytime the denominator equals 0. Well, looking at the factored form, the denominator is 0 when x is negative 5 and when x is equal to 2. Therefore, our domain is going to be all real numbers except for negative 5 and 2. Next, find the vertical asymptotes. Well, when you go to find the vertical asymptotes, cover up any common factors between the numerator and the denominator. Notice in this case, I have an x minus 2 in the numerator and an x minus 2 in the denominator. Right? We can cancel those out, leaving us only with x plus 5. That means x equals negative 5 is going to be our vertical asymptote. After we identify vertical asymptotes, let's look for holes. Holes will occur at the remaining undefined values of x. So if it's not a vertical asymptote, in this case 2 is not a vertical asymptote, but the function is undefined, that means it is going to generate a hole. Generally speaking, if we have common factors between the numerator and denominator, that's going to result in holes. So here I have a hole when x equals 2. Now, to find the coordinates of that hole, I can plug in 2 for x into the simplified form of our function, or the form of the function where we have crossed out these common factors of x minus 2. That leaves me with 3 in the numerator divided by 7. Therefore, our whole is located at 2, 3/7. Next, we need to identify horizontal asymptote. To identify the horizontal asymptote, we look at the degree of the numerator and the degree of the denominator. In this case, the degree of the numerator is equal to the degree of the denominator, which means that I have a horizontal asymptote at y equals the ratio of the leading coefficients. Well, the leading coefficient of the numerator here is 1. The leading coefficient of the denominator here is also 1. If I take the ratio of 1 divided by 1, well, that leaves me with 1, giving me a horizontal asymptote at y equals 1. Next, let's find our x-intercepts. To find the x-intercepts, we need to find the zeros of the numerator that do not make our function undefined. Well, what makes the numerator 0? -1 and 2 make the numerator 0. However, we know that 2 is not in the domain. Therefore, my only x-intercept is going to be x equals -1. And because that's an x-intercept, we know that the corresponding y value is going to be 0. All right, when I plug in -1 for x, I get out 0 for y. I only have one x-intercept in this case. Next, we want to find the y-intercept. To find the y-intercept, we plug in 0 into our function. Now, it doesn't matter which function, which form you plug it into. All right, I think that the original form here is actually easier. If we plug in 0 for x, we get -2 divided by -10, which reduces into 1/5. So we have a y-intercept at 0, 1/5. Once we have all this information, we can begin to sketch our graph. Start with our vertical asymptote. We have a vertical asymptote at x equals -5. Draw in your asymptotes with a dotted line. We have a whole at 2, 3/7. So I go to 2, 3/7. That's a little bit less than a half. So I'm going to put an open circle in my graph right there. Next, we have a horizontal asymptote at y equals 1. I can draw out my horizontal asymptote with a dotted line. Then we can plot our intercepts. We have an x-intercept at -1, 0. That's going to be right here on our graph. And we have a y-intercept at 0, 1/5. Right? That's going to be right around here. So plot those points. Plot the x and the y-intercepts. Now, we need to plot some additional points between and beyond each vertical asymptote and each 0. Okay, between and beyond each vertical asymptote and each 0. So that means I need to plot some point over in this region. All right, pick a number that's easy for you to plug in. All right, pick a number that's easy to plug in. All right, in this particular case, I'm going to plug in -9. All right, you could also plug in any of these values of x that are to the left of -5. So if I plug in -9, and you can do this in the simplified form where we have these common factors canceled out, if I plug in -9 for x, -9 plus 1 gives me -8, -9 plus 5 gives me -4, -8 divided by -4 gives me a +2. So I'm going to have a point at -9, +2. -9, +2. There I have that point. So what does this mean for my graph? In this region, all right, my graph has to, as it goes to the left, it has to approach the horizontal asymptote. As it goes to the right and approaches this vertical asymptote, it can do one of two things. The graph can either go up or the graph can go down. In this case, the graph must go up. It must go up as it approaches this vertical asymptote, because if it went down, that would require it to cross the x-axis, meaning that there would have to be an x-intercept. But because there is no x-intercept here, we know that the graph must go up. So that's what our graph is going to look like in this particular region. Now, I need to plot another point between this vertical asymptote and my 0 at -1. So I could plug in any value of x between -1 and -5. All right, I'm going to plug in -4. And again, it's easiest to do that in the simplified form of our function. So don't worry about these common factors here. Let's just plug in -4. -4 plus 1 gives me -3. -4 plus 5 gives me +1. -3 divided by +1 gives me a -3. So I have a -4, -3. I can plot that point. All right, there I have my ordered pair, -4, -3. So what does my graph have to do in this region? Well, as my graph goes to the left of this point and approaches this vertical asymptote, again, my only options are to go up or down. Because there is no x-intercept here, that means my graph must go down towards -infinity as it approaches this vertical asymptote. Now, as my graph goes to the right of this point at -4, -3, it's going to approach this x-intercept, cross through the x-intercept, go through the y-intercept, go through this hole in our graph, and as the graph goes to the right, it must approach the horizontal asymptote. This gives us our final shape of our graph. There is example number 1 of graphing rational functions.